Hello students, I am Dr. Himanshu Sarkar. Welcome to all of you in my YouTube channel. In my previous lecture, I had given the concept of the dipole and I was discussing in my last lecture, that is the how to find the electric field intensity due to dipole in the end-on position. End-on position means what? I told you, axial outside position. And in my last lecture, I also discussed up to this. That is, this is a dipole. This is minus q charge, this is plus q charge. Total length is L, this is the center of the dipole. I have to find intensity on the axial point P. P is what? P is at a distance r from the center of the dipole. I have calculated the intensity due to the plus q charge. I have calculated, that is what? That is electric field intensity at point P due to plus q charge, that is U1 is equal to 1 by 4 pi epsilon 0 q by r plus L square. Why? From here to here distance is what? R. From here to here distance is what? L. So what? R plus L square. And the direction is what? This is the positive charge, this is a positive charge. So direction of intensity is this direction, positive repulsion. So E1 is this. Similarly, electric field intensity at point P due to minus q charge is E2. It is equal to 1 by 4 epsilon 0 q by r minus L square, that's equation 2. And what is the direction? That is a minus charge. Here is a positive charge. At point P, what we assume? Assume unit positive charge at P. That is by definition of the intensity already I have discussed in my previous lectures. So that is E2 is equal to this. This distance how much? From here to here R, from here to here L. So this distance how much? R minus L distance. So intensity formula is this. Now intensity is a vector quantity. So E1 is function in this direction, E2 function in this direction. That is E1 and E2 opposite direction. You know how to find result from the two vectors? If the two vectors in opposite direction, that is the net intensity at point P is E is equal to E2 minus E1. Okay. So I can now write down E is equal to what? E is equal to E2 minus E1. That is equal to what? That is equal to 1 by 4 pi epsilon naught into Q into E2 is what? 1 by R minus L whole square minus 1 by R plus L whole square. I think all of you clear. Again I am saying intensity is a vector quantity. Two vectors E1, E2 opposite direction. So resultant or net intensity is equal to what? E2 minus E1. Okay. So now we can write down, that is 1 by 4 pi epsilon naught into Q into what? R square minus L square whole square into this what? R plus L whole square minus R minus L whole square. That is equal to what? 1 by 4 pi epsilon naught into Q into what is it? R square L square. Cancel out. That is R square plus L square plus 2RL minus R square minus L square plus 2RL by R square minus L square whole square. R square L square cancel out. So I can write down 1 by 4 pi epsilon naught into Q into 4RL by R square minus L square whole square. You know P is called 2ql called dipole moment. So you can write down 1 by 4 pi epsilon naught into that you can write down as 2r into 2ql by r square minus l square whole square. That is 4qrl means 2r into 2ql. 2ql is what? Dipole moment. So I can write down what is the electric field intensity? Answer is what? 1 by 4 pi epsilon naught into 2pr by r square minus l square whole square. This formula is very much important who will appear for the ISC exam. This is very much important formula, that is the electric field intensity due to dipole in the end-on position. Now I consider there is an approximation called short dipole approximation. Short dipole approximation. If we consider a short dipole, what is the meaning of short dipole? Length of the dipole, suppose a dipole plus q minus q. Length of the dipole is very small compared to the point of observation. That is called short dipole. Clear? So for short dipole approximation, write down L is very small compared to R. Then E is equal to what? 1 by 4 pi epsilon naught into 2pr. This L is neglected compared to R. So this what? R to the power 4. So R, this cancel out. So E is equal to 1 by 4 pi epsilon naught into 2p by RQ. That is the E. This formula is very, very important formula. I think students, clear to all of you. Now, if you have any query, any question, you can ask me in WhatsApp. So, I think all of you clear, no problem. Now, I am stopping my class here. Thank you. In my next class, I will discuss broadside position electric field intensity due to dipole. Okay, thank you.